Hi students, now let's discuss the 10th problem from exercise 5.2. We are given the function f of x is equal to greatest integer function of x defined in the interval 0 to 3, and we are asked to prove that f of x is not differentiable at x is equal to 1 and x is equal to 2. So before proceeding into the proof, let's recall what greatest integer function of x represents. Suppose x belongs to the interval open interval 0 to 1, then the greatest integer function of x is equal to 0 for all x, because it is the greatest integer which is less than x. So if x lies between 0 and 1, then the greatest integer which is less than x is 0. So the greatest integer function of x for all x in the interval 0 to 1 is 0. Similarly, for all x belongs to 1 to 2, the greatest integer function of x will be equal to 1. And for all x belongs to a comma b, where a and b are integers, where a comma b are integers, then the greatest integer function of x will be equal to a. What about the value of greatest integer function of x for integer values of x? Suppose we have x is equal to 1. So at x is equal to 1, greatest integer function of x, that is equal to greatest integer function of 1, it will be 1, because by definition it is the greatest integer less than or equal to x. So the integers less than or equal to 1 are 1, 0, minus 1, minus 2, etc. And the greatest among them is 1. So the greatest integer function at c for all c integer values of c, greatest integer function of c is equal to c. So with this recollection, now let's try to verify, or let's try to prove that the greatest integer function of x is not differentiable at x is equal to 1 and x is equal to 2 for f of x equal to greatest integer function of x at 0 less than x less than 3. So before proving it for a particular case, let's prove the result for a general case. Let's prove the greatest integer function of x is not differentiable for any integer value of x. So we try to prove greatest integer function of x is not differentiable for any integer value of x. Then the result easily follows, because 1 and 2 are integers. Now let c be any integer. It could be positive or negative. Let C be an integer. By definition of derivative, we know f dash of C exists. F dash of C is defined if limit for a small incremental value of C called delta C, limit delta C tends to 0, f of C plus delta C minus f of C by delta C exists. So if this limit exists, we say f dash of C exists. Now, for a particular function, if f of x is a greatest integer function of x, then limit for f of x is equal to greatest integer function of x, f dash of c is equal to limit delta c tends to 0, f of c plus delta c minus f of c by delta c, where c is any integer. Now consider if this limit exists, then we say f is differentiable for all c belongs to z. If this limit does not exist, then we say f dash of c does not exist, that is f is not differentiable for any integer value of c. Now let's consider the left hand limit. So that is limit delta c tends to 0 minus f of c plus delta c minus f of c by delta c. So that can be evaluated by limit h tends to 0 f of c plus 0 minus h minus f of c by h. Since c is an integer value, for the value c minus h, the greatest integer function of c minus h minus greatest integer function of c by it is 0 minus h. So we have minus h. So by definition of greatest integer function and c being an integer value, so c minus h will be the preceding integer of c, that is c minus 1 minus c by minus h, that is equal to limit h tends to 0, 1 by h is equal to infinity. Now consider the right hand limit. So the right hand limit, from this itself it's clear that left hand limit does not exist, therefore the limit does not exist. Well, anyway, let's verify the right hand limit. That is limit delta c tends to 0 plus f of c plus delta c minus f of c by delta c, that is equal to limit h tends to 0 f of c plus 0 plus h minus f of c by 0 plus h. So by definition of f of x, it is equal to limit h tends to 0, greatest integer function of c plus h minus greatest integer function of c by h. Since h is a very small incremental value, it lies in the interval c plus h will lie in the interval c to c plus 1 as h is very small. Therefore, the greatest integer function of c plus h is equal to c, c being an integer. Therefore, it is c minus c by h, that is equal to 0. This implies limit delta c tends to 0, f of c plus delta c minus f of c by delta c does not exist for c belongs to an integer. Whenever c is an integer, the limit does not exist. So this implies f of x equal to greatest integer function of x is not differentiable for all x belongs to integers. So this implies f of x is equal to greatest integer function of x for 0 less than x less than 3 is not differentiable at any integer value in that interval. The integer values in this interval are x equal to 1 and x is equal to 2. Hence the proof. Thank you.